In this section, we will explore what it means to have rational exponents or fractional exponents. When you hear or read the word rational, just think fractional. So then this section is really talking about how do we evaluate expressions or simplify expressions when there is a fraction as the exponent. To get us started, I want you to consider the number square root of 7. If I take the square root of 7 and if I square it, I get 7, right? Because after all, the squaring action cancels out the square root action. Now I want you to consider the expression 7 raised to the 1/2 power. That's a fractional or rational exponent. If I take this number and I square it, I get 7 to the power of 1/2 times 2, correct? By the product rule of exponents, you would multiply these two powers, and you would then get 7 to the first power, which is just 7. So, because we see that the square of 7 to the 1/2 and the square of the square root of 7 are both equal to 7, we define 7 to the 1/2 power to be the square root of 7. So then what I'm saying is we have 7 to the 1/2 power is the square root of 7. I want you to notice that the index right here that is not written is understood to be 2, right? So that means, or that leads us to believe, that 7 to the 1/3 would be the cube root of 7. 7 to the 1/4 power would be the 4th root of 7, and so forth. So we have this rule that says x raised to the power of 1 over n is equal to the nth root of x. So the main thing I want you to really take with you is the denominator of your rational exponent is the index when written in radical notation. So I really want you to notice that this is your index. The denominator of your fractional exponent always represents your index. It tells you what kind of root you're finding: a square root, a cube root, a 4th root, and so forth. So look at this first example. Evaluate 25 raised to the power of 1/2. Well, 25 raised to the 1/2 then, remember that the denominator of your fractional exponent represents the index in radical notation. Therefore, your index is 2, which means we're talking about a square root here. So 25 raised to the 1/2 power just means the principal square root of 25, which is 5. So the answer is 5. Here we have 81/16 or 81 over 16 raised to the power of 1/4. So what does this mean? Well, the 4 in the denominator of your rational exponent means the 4th root of 81/16. So the 4th root of 81/16. So if you have become familiar with some of your perfect fourths, you'll know that the 4th root of 81 is 3. The 4th root of 16 is 2. That is to say, if you raise 3 to the 4th power, you get 81, and if you raise 2 to the 4th power, you get 16. So 3/2 is the evaluation of 81 over 16 raised to the 1/4 power. Here we have negative 32 raised to the power of 1/5. I want you to notice where the negative is. It's on the outside of these parentheses, so make sure it stays on the outside of your notation here, of your radical notation. So this would mean really read it as the opposite of 32 raised to the 1/5. So the opposite of the 5th root of 32, okay? Notice how the negative is on the outside, the negative is on the outside. Now, we all know that the 5th root of 32 is 2, so the opposite of 2 is negative 2. All right. Here we have negative 125 raised to the power of 1/3, but notice that the negative is on the inside of the parentheses. So when I rewrite this using radical notation, the negative will be on the inside of my radical. So basically part of the radicand. Now this is to the power of 1/3, so this would be the cube root of negative 125. The cube root of negative 125 is negative 5, because negative 5 cubed is negative 125. Now in example 2, they're going to throw in some variables, so the instructions will not say evaluate, they will say simplify. All right, so notice that the exponent is 1/3. That means everything that is inside of the parentheses will be underneath a cube root. So it'll be the cube root of everything that's inside the parentheses. So negative 27m cubed, like that. All right, the cube root of negative 27 is negative 3. And do you remember this trick that I promised that I would show you how I derived it later on? But 3 divided by 3 is 1. So then this will just be m to the first power. So negative 3m is the cube root of negative 27m cubed. Meaning, if you were to cube this expression, you would get negative 27m cubed. Check this one out. Negative 1 raised to the power of 1/6. So when I rewrite this, it will be the 6th root of negative 1. Now, in the previous lesson, we talked about how whenever the index is even, the radicand cannot be negative, or else you get not a real number. I want to remind you that at the end of chapter 9, we will have a solution for something like this. It will be imaginary, or you can say it will be complex. But at this point in our lesson, in our studies, this is what we have at the moment. Whenever the index is even, whenever you're trying to find an even root, then the radicand has to be positive, or else you're going to get not a real number. But whenever you're finding an odd root, the radicand can be negative. That's fine. Now, I'm not sure you noticed, but all of the numerators of our fractional exponents have been 1. So what happens when you have an expression that's raised to a fractional exponent and the numerator is something other than 1, like maybe like 2/3? What does this mean? Well, let's consider. This would be the same thing as 8 to the 1/3 power and then squared. We know that by the product rule, or excuse me, the power rule of exponents would tell us to multiply these two. And then this inside the parentheses can be rewritten to mean the cube root of 8. And then don't forget quantity squared. And then the cube root of 8 is 2, and that has to be squared. So the evaluation would be 4. So notice that this notation, 8 raised to the 2/3 power, means find the cube root of 8 and then square it. Find the cube root of 8 and then square it. So then in general, x to the power of m over n, where m is not necessarily 1, right, just means find the nth root of x and then raise it to the power of m. So this notation can be rewritten with this radical notation. So here we have 25 raised to the power of 3/2. All right, so what this means is the square root of 25 is what we need to find, and then raise it to the 3rd power. So the square root of 25, we know it to be 5, and then 5 raised to the 3rd power gives you 125. So this is the evaluation. 16 raised to the power of 3/4 will be the 4th root of 16, and then when you're done finding that 4th root, raise it to the power of 3. Now the 4th root of 16 is 2, and then when you raise 2 to the 3rd power, you get 8. So 8 is the evaluation. I hope you're getting this. All right, now we have negative 27 raised to the power of 4/3. So let's see. It'll be negative 27 as the radicand. It'll be the cube root of negative 27, and then raised to the power of 4. Now we know the cube root of negative 27 is negative 3, and then I need to raise it to the power of 4. The parentheses here are extremely important, and you get 81 as the evaluation. Positive 81, that's really important. All right, now we have negative 1/8 raised to the power of 2/3. Please keep in mind that the negative must stay on the outside of our radical notation because that's where it is at the moment. It's outside of the parentheses, right? So we're going to have 1/8 as our radicand. It'll be the cube root of 1/8. And then, watch this, squared. But it's important that the negative is on the outside of the parentheses, because if the negative were on the inside here, right, if you had parentheses around all of this, then you would end up squaring the negative and then you would get a positive answer, which would be wrong because the negative is not part of what's being squared, right? The negative is on the outside. So again, notation, notation, notation. Keep the negative on the outside. The cube root of 1/8 is 1/2, and then you need to square it. Keep that negative on the outside. 1/2 squared is 1/4, and then you have a negative on that. So negative 1/4 is the evaluation. All right, the instructions say simplify now because there's some variables as well, all right? So here we go. Everything inside of the parentheses becomes your radicand. So here's my radical, here's my radicand. Now the denominator of my fractional exponent is 2, so this is the square root. And then so the 2 is assumed to be there, right? The 2 for the square root. And then I need to raise this to the power of 3, all right? Now, the square root of 9y to the 4th, right? The square root of 9 is 3. Now, watch this. 4 divided by 2 is 2, right? So this will be y squared. Don't forget, we need to cube this square root. So 3 cubed is 27. Y squared cubed is y to the 6th, because you would multiply these two by the power rule. All right, cool. All right, we have negative 8, a cubed, b cubed, all of that raised to the power of 2/3. So this would be a great time for you to pause the video and see if you can rewrite this expression using a radical. And then I'll check back with you once you're done. All right, let's see how you did. So everything inside of the parentheses is your radicand. This is going to be a cube root and then squared when you're done, okay? So the cube root of negative 8 is negative 2, and then the cube root of a cubed is a, the cube root of b cubed is b. Don't forget, you have to square this, right? Let's move this up, and then this would mean negative 2 squared is positive 4, a squared is a squared, and b squared is b squared. So this is the final answer. How did you do? All right, we have negative 32r to the 15th power and then raised to the 3/5. All right, so everything in the parentheses is your radicand. So 32r to the 15th power is your radicand. This will be the 5th root and then raised to the 3rd power, right? The negative that's on the outside of the expression remains on the outside of the expression. All right, now the negative is on the outside. And then the 5th root of 32 is 2. And then watch this. 15 divided by 5 is 3. So this will be r cubed. Now don't forget, you have to cube this 5th root, right? Keep the negative on the outside. 2 cubed is 8. R cubed is r to the 9th. So that is our final answer. All right, you guys, the last thing that we want to discuss in this section is what do we do with negative rational exponents? To get us started with that conversation, consider simplifying this expression. All right, now there's a few ways you can simplify this expression, 3 squared divided by 3 to the 5th. One way is by using something called the quotient rule for exponents, which says to subtract the exponents. You would do 2 minus 5, and that would give you 3 to the negative third power. But then if you're not familiar with negative exponents, you might think, well, what do I do with that? Like, what does a negative exponent mean? So let me have you simplify this expression a different way using factorization. 3 squared means 3 times 3. 3 to the 5th power means 3 times 3 times 3 times 3 times 3. Now watch this. This 3 divides out with that 3, right? This 3 divides out with that 3. So then what you end up with is 1 over 3 cubed. So if 3 squared divided by 3 to the 5th power is 3 to the negative third, and 3 squared divided by 3 to the 5th power is also 1 over 3 cubed, that leads me to believe that 3 to the negative third power just means 1 over 3 cubed. So negative exponents reciprocate your expression, right? Instead of 3 to the power of 3, now you have 1 over 3 to the power of 3. The job of the negative as an exponent is to reciprocate your expression. So if you have something, this is more general now, x raised to the power of negative m over n, the job of the negative is to reciprocate your whole expression, right? And notice here that once your expression has been reciprocated, the exponent is no longer negative. It's gone. The negative is gone, all right? Now, if the expression is written like this, if this is how it's written when it comes to you, then the job of the negative here is to reciprocate your expression. So instead of 1 over x, it'll be just x to the power of m over n. So then this expression, 16 raised to the power of negative 1/2, would just mean 1 over 16 raised to the positive 1/2. Okay? So then this would be 1 over, let's continue simplifying, the square root of 16, which is just 1 over 4. So a quarter, 1/4 is the evaluation of this expression. Now this expression here does not have a negative exponent, so be very careful. It's only the negative in the exponent that reciprocates an expression. So here there's nothing reciprocating at all. So this just means the cube root of negative 8 and then squared, okay? So don't go flip happy, right? Don't go reciprocating everything. It's only when you have a negative as an exponent. The cube root of negative 8 is negative 2, and then I have to square it, so this becomes 4. Now here's a good one. Negative 27 x cubed, all raised to the power of negative 2/3. Now, the first thing I suggest you to do is to take care of that negative in the exponent, right? So in other words, reciprocate this right away. So it becomes 1 over, and then you got negative 27x cubed. Now, let me fix that exponent there. It's a little sloppy. Negative 27x cubed. Now all of that raised to the power of positive 2/3. Okay, did you see that? So now I'll continue simplifying. So it's 1 over, and then this right here means the cube root of everything in the parentheses. So I'll rewrite this as the cube root of negative 27x cubed. And then don't forget that we have to square this, right? We have to square it. All right, let me move the screen up for us. So continuing to simplify would give us, let's see, 1 over. Now the cube root of negative 27 is negative 3. The cube root of x cubed is x. But again, don't forget you have to square this. So your final answer is positive 1 over 9x squared. Okay, that is a 2 right there. All right. I think that made it worse. All right. There we go. So this is your final simplification of that answer. All right. We have 1 over 8 to the negative 2/3. Now, the negative is on an expression that's already in the denominator. So then what this negative does is reciprocates this expression. So instead of 1 over 8, it becomes 8, right? So just 8 raised to the power of positive 2/3. And then we just continue simplifying this as the cube root of 8. I think we did this earlier, this one. And then squared. So this just becomes 2 squared, which is 4. All right. So we know how to handle negative exponents, negative fractional or negative rational exponents.